Here's the second recording. And in this second recording, what we'll do is we will go through and write these systems of inequalities. So now we're being given word problems. And from the time that I spent tutoring last semester, when I was still an intern at Marion Graham, I tutored at a math place called Mathnasium. And I know that most of the time, students hate word problems. That is the one part of the problem that they struggle with the most. So I'm going to walk you through a bit how I would approach this word problem, how I would look at this if I were a grade 11 student, and then I would go from there. So the steps that we've been given here are define your variables and identify restrictions, write a system of inequalities to represent the situation and graph the system, and then answer the questions below. So the last thing that we do is answer the question. Jonah is going to the store to buy candles. Sorry, Jonah, I don't care. It could be Marty McFly for all I care. I don't really bother with the fact that he's going to the store to buy candles. That means nothing to me. When I'm reading through this, I see a couple pieces of information. I see that small candles cost $3. Sometimes I put a little triangle above those just to link them. Large candles cost $5. Awesome. There's another piece of information. He needs to buy at least 20 candles and cannot spend more than $80. Those are really, really key pieces of information. And probably what I would do is I would underline those. If it ever lets me underline, I would underline those so that I know that those pieces of information must be met. And then the last part here is we're given our little instructions, which says write and graph a system of linear inequalities that represent this situation. So all of the question appears in these two sentences here. Small candles cost $3, large candles cost $5. He needs to buy at least 20 candles, can't spend more than $80. There's 4 pieces of information there. The absolute first thing that I would do is when I'm looking at this, I would see the little statement of graph this system of linear inequalities, and I'd say, all right, I gotta call something X. I'm gonna call these little small candles that cost $3, I'm gonna call those X. The large candles that cost $5, I'm gonna call those Y. At the very least, I know that this is gonna be influencing where the graph is going, and the small candles and the large candles, those will influence the lines of the graph. The other thing that I would know is my 2 little underlined pieces of information here. One of which says I need at least 20 candles. I need at least 20 candles, which means that I can buy more candles, and that's okay. I can be Jan Levinson Gould from The Office, and I can start my own candle factory. And the other thing that I know is that you cannot spend more than $80. So that means that the absolute maximum that I can have, I can spend $80 or I can spend less than that, and that is fine. So what I would do here is I would look at this scenario. I'd say small candles cost $3, large candles cost $5. I need to buy at least 20 candles. Well, if I'm buying small candles and large candles, I know that the number of small candles I buy, X, and the number of large candles I buy must be at least 20. It must be greater than or equal to 20. So that's one of my equations there. The second equation is I know that I cannot spend more than $80. Well, I know that I have to buy at least 20, so I still need to talk in terms of X and Y. But now what I'm going to talk in terms of is I'm going to say, well, small candles cost me $3, and large candles cost me $5. So the number Y of large candles I buy times $5 has to be less than $80. The number of small candles, X, times $3 must be less than $80. So when I add those two together, it has to be less than 80. So I am going to draw this here, like this. Let's see if I can line those up. I can't. Look at that. Awesome. I'll talk about in a sec why I drew my graph like this. We'll get to that in a second. The other thing that we usually had with our questions here is we usually had like an XEN or an XER or an XEI. So what we need to figure out is, if we buy candles, are we dealing with natural numbers? In other words, can we buy 0 of a certain type of candle? Are we dealing with whole numbers, meaning you can buy only positive candles, or are we dealing with integers where we can somehow buy a negative number of candles? Can I exchange 6 big candles for 3 smaller candles? And the answer is no, we cannot. The answer is also that yes, we can buy 0 candles, and that's perfectly acceptable. So what that means then is that x can be any whole number, and y can also be any whole number for this first equation. The second question we need to ask then is $80, 3x plus 5y. Can I buy half a candle for $1.50? I can't. And so what that means is that this will also be x can be any whole number and y can be any whole number. I'm going to fix that little y here. Awesome. So we have our 2 equations. What we always did in the past was we said, great, let's take those 2 equations, let's figure out what the intercepts are, and let's go from there. I'm going to draw my little dots to show you what color is what. Red will be the bottom equation. Black will be the top equation. And let's figure out what the intercepts are. Well, if I plug in a 0 for x here, let's actually move these down a bit here. Let's move this. Move this down there. Okay, if I have x equal to 0, 20 can be equal to y. And same thing, I can also say 20 if y is equal to 0 can be less than or equal to x. So that means that for this first graph, my intercepts will be 20 and they will be 20. So I need to count down. 1, 2, 3, 4, 5 down. Okay. 1, 2, 3, 4, 5 down. So I graphed this previously when I was planning for this lesson. I know that that point needs to come 1, 2, 3, 4, 5 spaces down. Is that right? It should be 4 spaces down, not 5. Ooh, that's going to be a tough one to erase. 1, 4, 5 right here is where it needs to go. Right there, okay. And then this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's about right. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so that's my first little black point there, my first little line, and I'm going to connect these two. And I'm also going to do something a little bit interesting. In the past, I've been graphing it with a line that has arrows at the end of it, assuming that it will continue on for forever. In this case, I'm not going to do that. And here's why. I know, and this is also why I put my axis in the very bottom left-hand corner here, is I know that I cannot buy a negative number of candles. Okay, I know that I cannot, under any circumstance, trade in a candle. And so as such, I know that everything must be in the positive axis. So I could extend this graph, sure, and draw it like this, but there's no point. There will be no points over here. There will be no points down here. There will be no points down here. Because in all 3 of those quadrants, there are negative values. So I'm going to just actually erase those. I don't need them. And like I said, I am going to just draw a point from right here to, if it lets me have control of this, right there. Point from right there to right there. So that's my first line. That's that first equation there. And then we want to deal with this second equation here. We want to set x and y equal to 0 again. So 80 greater than or equal to, let's set y equal to 0 first. We have 3x. I would need to divide both sides by 3. And when I do that, I'm actually going to get a decimal point. because 80 divided by 3 is in fact 26.6. 26.6 repeating is equal to x. And then for the other one, I have 80, and I'm going to set x equal to 0. 80 is greater than or equal to 5y. And in that case, y can be equal to 16. And so that is my second set of intercepts there. I know that 26.6 will be my x, so that's 20, 21, 22, 23, 24, 25, 26.6 will put me right about there. 16, if this was 20, 19, 18, 17, 16 will put me right there. And like I did last time, I am not going to draw a line with arrows on it because, again, that would be redundant. There is no point in me doing that because we cannot have a negative number of candles. I'll draw my graph out like that. Okay, so we have our two graphs, and now we have the same problem that we had previously. We can fit them in quadrant 1, quadrant 2, quadrant 3, quadrant 4. One of those 4 quadrants we can fit it within. I'm going to say, based on my knowledge of how I set up these equations, I'm going to say that quadrant 1 probably is not the correct answer. And here's why. I'm going to say that quadrant 1 is me spending more than $80 or me buying, so it would be me spending more than $80. This red graph here, we said that we don't want it to be above the red axis here. We don't want it to be above the red line. We want it to be below the red line. If we spent, so let's say, for example, we bought this many candles, that would be me spending more than $80, which I said I do not want to do. So I can erase that. There's one of my common sense, or not so common sense answers that I can use. The other point that I'm going to pick on a little bit here is this number 2 point over here. I'm going to pick on this point. And the reason that I'm going to pick on that point there is I'm going to say I don't like this particular point or this particular region because that would be for me, again, it's above the red line, so that would be me spending more than $80, which I said was unacceptable. Ooh, big mistake by me. Okay. The last thing that I said is I need to spend more than, or I need to get more than 20 candles. And so we said that anything greater than 20 was acceptable. Well, this point down here, right beside the little 4, that point was if I had bought 20 of these small candles. And so I said, well, great, I can buy any more. I can buy this many small candles, and that's totally fine according to the black line. I just need to be on this side of the black line. So I haven't actually tested any of these points, but I can already prove that, in fact, I know that region 4 is the correct answer of where I can buy candles. Region 4 right here. I'm going to shade this in really poorly. Awesome. Now we can satisfy the last part of our equations, which were that XEW and YEW, meaning that it can only be the whole numbers. So only on these points. That point there fits, that point there fits. Awesome. All right. So if someone wouldn't mind unmuting themselves and answering this question, that'd be great. What does the intersection point represent? Is it a possible solution? Can someone help me with that? What does this intersection point mean? So we didn't really highlight it much here, but both equations were equal to, that was the point of intersection. It looks like it doesn't actually fall on a real point. It looks like it's falling kind of in the middle here. So is it a possible solution, and what does that point of intersection mean? Who can help me out with that? Anybody want to supply a solution to that one? Okay, I'm going to pick on someone then. Mackenzie, I haven't heard your voice in about a month. That intersection point, is it a possible solution? And what does that point actually represent? Okay. Why do you think it would be a possible solution? What would tell you that it would be? Okay. Yeah, exactly. Um, so I agree with for sure one of the things Mackenzie said, which was that this blue point here would be me spending $80 and getting exactly 20 candles. That's exactly correct. I would disagree that this is not a potential solution, and here's why. For me to spend that exact amount of dollars and get a point that isn't actually on one of these intersecting points here. So like all of these values down here, they all are at where the y and x axis are crossing each other. Because it's not exactly on one of those points, that would be the equivalent of me buying, let's say, 27.3 candles. And in fact, we could figure that out. This would be the equivalent of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I don't know, let's say 11.3 candles is how many candles I would have bought. And we had said that it is impossible for you to buy 11.3 candles. You can't buy a third of a candle. So it is not a possible solution, but what that point represents is exactly $80 and exactly 20 candles is what that point represents. Awesome. So if we were to do this part B here, what we would do is we would pick a point and make sure that it satisfies, which means that it fits into and makes right both of the inequalities. So I'm going to choose, let's choose, so this will be my blue little circle here. Let's choose this point here. And this is the point 21. So this is the point 21 for my x value and 1 for my y value. So what we would do is we would take that value there, and we would say 20 is less than or equal to x plus y. Let's plug in our values. 20 should be less than or equal to 21 plus 1, and in fact 20 is less than 22. Perfect, so that one's good. And then to satisfy the other one, we would say 80 must be greater than or equal to 3x plus 5y. 80 must be greater than or equal to 3 times 21 plus 5 times 1. 3 times 21 is 63 plus 5. 5 times 1 is 5. And 80 is, in fact, bigger than 68. So that means that, yes, we have found a possible solution. That is one of the potential correct answers. All right. Last question here. And then I'll upload. Again, someone messaged me and said that the video was being a little bit choppy today. I'm going to blame that on my roommate watching Netflix. But I'll post this to YouTube here so that if something was super like fuzzy at one point or you didn't totally understand what I was saying, you can go back and watch it there. Last question here. I haven't done this one yet, so I may ask for some assistance, so be prepared. I think it's easiest if I just call on you, which can get super embarrassing, and Mackenzie speaking definitely scared me a little bit because it was just so loud in my ears out of nowhere. But we're going to do that. So a student club is hosting a fundraiser banquet to raise money for a charity. For every cupcake sold, $4 goes to charity. For every teddy bear sold, $10 goes to charity. They want to raise at least $100. They need to sell at least 8 teddy bears to cover their initial cost. for ordering the bears. Michael Puto, you're gonna help me out, sir. What would you like to set as our x value? You got a really tough one. 4 and 3. Where do you see 3? Okay. Well, let's think about this. What two things are we selling? Great. Which one do you want to be x? Okay. What do you want to be y then? Lovely. Oh, no. We're not there yet. Sarah, can you give us one of the equations that we'll need? And I would like you to give me the equation. You know what? You pick your favorite. Can you give us one of the potential equations that we'll need here? Yep, I can hear you. Okay, I'm going to put equals for now. Equals 4x plus 10y. I like it. So I like the 4x and 10y. 4x because $4 goes to charity. 10y because $10 is a teddy bear. What sign should we use instead of the equal sign? I'm going to disagree with you there. Other way around, thank you. Yeah, should be less than or equal to. No, it's okay. No worries. Okay, there's one of our equations. Ooh, who do I want to pick on now? Heidi McGregor. Oh, that was either really laggy or that was you complaining. One of the two. Okay, awesome. All I heard was why. And that was it. Okay, what's the other equation that we need here? Okay. Not a bad idea. I like it. So let's think about this for a little bit. You need to sell at least 8 teddy bears. We had said that y would equal a teddy bear being sold. So right away, I want to fix that for sure. And I want to put a y there. The other thing that I want to think about here is I don't really need the dollar value at all. I don't really care that this is $10. I know that I just need to sell 8 teddy bears at the very, very least. And so I agree with this little equation here. 8 is less than or equal to y. I would like someone to argue for the fact that these should be less than or equal to, and I'd like someone to argue against the fact that it should be less than or equal to. Ethan, why should they be less than or equal to in this case? Or shouldn't they be? This is where we get to see if Ethan is paying attention. And it appears he is not. Julia, can you help us out with that one? Oh my word, Ethan. Okay, Ethan's up now. You blew it. Should they be equal signs or should they not be equal signs? What do you think? Yes. Should they be greater or these are both less than or equal to signs. Should they have the equal sign or should they not? Okay. We have actually indicated that here. We've said that this can be bigger than $100, so that's fine. What I'm more concerned about is like this little equal sign here. Should they be there or should they not be there? Yes. Yes. Okay. Okay. Awesome. So the wording, Ethan. Yeah, you're off the hook now for a little while. Good job. Julia's up next though. So the next question I ask Julia, be ready to unmute yourself. It'll probably be question A. So start thinking about that one. So yeah, we can have the equal sign here. The wording of this question is very important. We need to sell at least 8 teddy bears. So that means I can sell 8 teddy bears and be satisfied with this equation. The other thing worth noting is if this would have said you need to sell more than 8 teddy bears, well, then that equal sign would not be able to be there. You would not be able to keep that equal sign there because you need to have, in fact, more sold than 8. I'm again going to draw my axis in the same way that I did with the last equation that we did. And the reason that I'm going to do that is because, again, we are not going to sell or return cupcakes. We're not going to have a negative number of teddy bears sold. That would be redundant if I'm doing a fundraiser. So I want to graph these two equations here. I know that 8 must be less than or equal to y. So that means that 1, 2, 3, 4, 5, 6, 7, 8. No, I lost that point. 1, 2, 3, 4, 5, 6, 7, 8. At this point here, we need to at least meet this threshold here. At least sell this many teddy bears. And what I'm actually going to do here is I'm going to put a little arrow this way because this can, in fact, extend forever in the right direction, but not in the left direction. And then for the top equation there, we're actually just I'm going to use Desmos for this one because I think it's easier. So the equation that we have there is 4x, what did we have? I forget what we wrote down. 100 must be less than or equal to 4x plus 10y. And let's see this graph here. Okay, so that's what the graph looks like. We have intercepts, a y-intercept of 10, an x-intercept of 25. So we have a y-intercept of, that was 8, 9, 10. X-intercept of 25, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, right there. And like we did the last time, it would be redundant of us to sell negative cupcakes or negative teddy bears. So we are going to just connect this dot with a straight line. That got messed up at the end there. Connect that there, and we'll do the same thing here. So we have our point of intersection there. And then we want to be able to solve. We want to be able to solve for this system of inequalities here. So again, we have 4 different quadrants to choose from. We have quadrant 1, quadrant 2, quadrant 3, quadrant 4. Julia, surprise, you have a question earlier than what you thought. Which quadrants, based on the red line, which quadrants do you think you can rule out? Which of the 4 sections there? Based on that red line, what do you think? Not sure, question mark? Oh, she left. She really didn't want to answer that. Who can I bug now? Let's bug Jaden Sue. Oh, Julia's typing. Let's just wait to see what Julia's typing. Her mic must not be working. Yeah, okay. Kind of figured that. Okay, no worries. Jaden, do you have... Mike is not working. I don't know a Michael. Oh, hi, Mike. Jaden, do you have a possible solution for us there? Which quadrants can we rule out? Yeah. Awesome. So for sure we can rule out those two. And then for this last one, I'm not entirely sure which ones that we could rule out. I would actually like to test one of these points and see which one we can in fact rule out. I am going to choose this test point right here in the little 2 area there. I'm going to choose that test point there, and that is an x value of 9, a y, or x value of 1, y value of 9. My bad. So 1, y value of 9, so that's that point there. And we're going to test it in, let's test it in that top equation there. So we want to test and see if 100 is in fact less than or equal to 4 times 1 plus 10 times 9. And we find out that in fact 100 is not less than 94. So we know that quadrant number 2 doesn't work. Now normally what I would do is I would tell you, you can just assume, I don't know if that's going to work. I would normally tell you, you can just assume that quadrant 1 is going to work, but we don't actually know if quadrant 1 is going to work. We don't know if this is a good fundraiser or not. It's possible that none of these solutions work. So let's try something. Let's try this point right here. And again, we're going to try that in the same equation. 100 must be less than or equal to 4x plus 10y. And this point here is not 1 comma 9. This point here is 1, 2, 3, 4, 5 comma 9. So let's test this one and see what happens. 100 less than or equal to 4 times 5 plus 10 times 9. And in fact, 100 is less than 110. Okay. So what that tells me then is that anything above this region here, anything above, fits within my answer scheme. So I can shade in all of this region up here. Okay. The last thing that we haven't addressed is we haven't addressed with either one of these equations whether we should be looking at whole numbers, natural numbers, or integers. So I'm going to pick on Cassie Hamilton. And I'm going to ask her, for this particular question, can we sell 0 cupcakes or 0 teddy bears? Is that something that's reasonable? Could we sell a negative number of cupcakes or teddy bears? And then the last question I'll ask you is, could we sell a fraction of a cupcake or a teddy bear? Is that an option that's been given to us? So Cassie, if you can unmute yourself, that would be great. So I'll ask you the first question, which is, can we sell a fractional number of teddy bears? And we'll see if her mic is working, because that would be awkward if it wasn't. Well, it appears not. She's typing as well, so I'm going to assume hers isn't working. Avery, is your mic working? Oh, this is stunning how few work. That's amazing. Who else haven't I picked on yet then? Matthew, does yours work? We're going to have everyone unmuted by the end of this. It'll be exciting. Think so? That'd be a nice addition, actually. I could do it. It wouldn't be hard. Well, since Michael unmuted himself, I'm going to pick on Michael. And your lovely singing voice. So, first question, Michael Puto. Should we and can we sell a fraction of a teddy bear? Can I sell a teddy bear's left arm at this fundraiser? No. Okay. We're just going to flip between a bunch of people then. Jaden, can I sell a negative number of teddy bears? Awesome. Ethan, can I sell an entire teddy bear or an entire cupcake? Okay, so should I choose a natural number, a whole number, or an integer then, based on the questions that I just asked? I agree. Because I can, in fact, sell 0 teddy bears, and that is okay. So what I need to put next to these equations then is I need to put a little comma and put XEW and YEW. Second equation was down here. I need to put XEW and I need to put YEW. And this would take me all day, and this would be a really good Bob Ross episode. I should hit up Bob Ross and tell him to graph linear inequalities. See how soothing that is. Yeah, okay. I'll hit up Bob Ross's son. Oh yeah, that I heard about that news. It's fascinating. We'll get Kim Jong-do soon. The second one. That was a French joke in case anyone was wondering. Thanks, Ethan. Yeah. Yeah. It kind of hurts when you guys are all muted and I make a really funny joke and I'm sitting here going, where's my laughter? Oh, wait, they're all muted. Great. Thanks, Ethan. I appreciate that. Okay. So I guess the question that we can kind of ask ourselves here is, what is the minimum number of teddy bears and cupcakes that they need to sell? And what we can do then is we can look at this bottom line here and say that, like, anything as long as we're above this top line here, we're satisfied with the results of this equation. And I'll graph this in Desmos as well, so it's a little bit neater, so that you can see it. So that was our one equation. The second equation was 8 is less than or equal to, was it y or x? It was y. So what we can see is that as long as we are positive and up in this quadrant here, there are an infinite number of solutions. I can keep zooming out forever and ever. And as long as we fit up here somewhere, we are satisfied. Because the requirements that we were given was we were told that we need to sell at least 8 teddy bears. The reason why we were not told, but we just said at least 8 teddy bears, which is where this horizontal line came from. And then after that, as long as we're selling 8 teddy bears, we can sell an infinite number of cupcakes. We were not given a limit on how many cupcakes we have to sell. So in terms of the minimum number, as long as we're selling the 8 teddy bears, we can sell, in terms of the number of cupcakes that we could sell 1 cupcake, we could sell 0 cupcakes, we could sell 3, 4, and an infinite number of cupcakes from there on out. Okay, so the first question then, I'm going to go back to Sarah for this one, is what does the y-intercept of the diagonal inequality represent? Is it a possible solution? So we are looking at that point right there, the y-intercept of the diagonal linear inequality. Is that one a possible solution, Sarah? It is. Yeah, awesome. Lovely. And that would be a scenario where we're selling 10 teddy bears and we're selling 0 cupcakes. So yeah, it fits within our correct answer. So it is a possible solution. What does the x-intercept of the diagonal inequality represent? Can I go back? Let's go back to Heidi for that one. The x-intercept of the diagonal linear equality. What does this value represent here? The blue line that I've drawn, the x-intercept of the diagonal linear inequality, so I'm pointing at it with 2 blue arrows. What does that value mean? Yeah, that's the money. And what does it have to do with how much money? Does it communicate a lot of information or not really? It's not in the green section, right? So in terms of the value of that information, there's not much. What that was telling us is that line originally was telling us how much more how many things we would have to sell to make more than $100. That's all it told us. But because it's not actually part of the solution set, it doesn't tell us very much. It's not a possible solution. It's really not telling us a whole lot of information. So actually, you stumbling over that answer was the best possible thing you could have done. Yeah, nice work. Okay, so that's this lesson here. I am going to stop the recording.